Thank you, everyone, for tuning into the Cloud Native of FM podcast. This is your co-host for the show. My name is Simon Safdar. I'm the host of Cloud Native podcast and also the CFC and CF ambassador. So let me give you a point hinters like what we are covering on today's episode. And we are talking about a Kubernetes operator, a definitive guide for platform engineers. I think we already are familiar with what Kubernetes operator are. So let me give you the insights what Kubernetes is for and what is the intent of the today's topic. Kubernetes operators are software extensions that make use of Kubernetes API to extend behavior. What do we need to know about how they work and what are the concrete benefits? Join us from the team Red Hat into the real world use cases where operators and CRDs have been instrumental in solving complex application deployment and management challenges. Moreover, how operators enable automation, scalability, and self healing in various scenarios. So, without any further delay, let's me go straight to Ross Crisp from Red Hat. And can you give your intro of where you are busy in these days?
Yes. Hi everyone. Thank you, Cyan, for this opportunity to share my passion, operators, Kubernetes operators. And so I've been a software engineer for, well, over 15 years. And I've been in release engineering, system admin, and tester. And throughout all that, it helped me lead to where I am right now, which is a cloud developer doing platform development for most of the time using Kubernetes, but we solve the problems that sometimes Kubernetes cannot help us solve, which is second-day operations for very complex softwares. So therefore, the Kubernetes operator helps with that. So I started at Red Hat about 3.5 years ago, and very fortunate to be on a wonderful team. And what we do is we run workshops to help people understand the Operator SDK framework, and itself is a framework to help build Kubernetes operators. So yeah, I'm happy to be here. Thank you.
Thank you very much once again, Rose, for joining us on the show. And let's start the agenda first today. And I think there are some very important questions I need to ask you today. So, number one, first up, we can talk about Kubernetes controller, and then we can shift our focus toward what the CRDs and the operators are. Can you shed some light on how existing controllers works in Kubernetes?
Oh, for sure. So Kubernetes out of the box comes with controllers, and there's a few of them. For example, like the replica set controller or the deployment controller and the daemon set controller. So what do they all do is inside of it there is a control loop, and the control loop watches the share state of the Kubernetes cluster through an API server and makes the changes and attempts to move the current state towards the desired state. So Kubernetes um, understands manifests. Manifests are the files that talk to the Kubernetes, and those manifest files are written in the declare way, not imperative. Imperative kind of means that you tell it what to do and it does. Declare way is I want you to do this, and you have to make sure that the state of your cluster remains the way I want you to do it. So declarative that way. So the most important thing, as I said, is the control loop. And within the control loop, there's the reconciler, and the reconciler watches the the current state and it compares to the desired state and then try to match it as best as it can. So they are the ones that, like I said, the ones that comes with Kubernetes, the deployment controller. So what it does is if I say, I want 2 pods in my cluster, the controller, the deployment controller will keep on watching. So if one pod somehow dies, it will bring another one up with an ephemeral kind of pod. So it's always watching with that. Um, there's also so I said there's a record set controller, the daemon deployment controller, the daemon set controller. There's also the job controller, which is very functional because if you have a job that you want to deploy onto the cluster, it will keep making sure that the job is deployed. If it's not, if something's happening, it will keep trying on every 5 seconds until the job is completed. So that's really, really helpful. And so controllers are the key, it's a key part of the Kubernetes system. And the model of using the controller in the control loop allows the Kubernetes to handle a wide range of workload types. From anything from a stateless web servers to a stateful databases, because we're always deploying that application, and the deployment controller watches over that. And so in essence, it provides a self-healing, and it can also do auto-scaling on top of that. That's why it makes Kubernetes so powerful at all these operational tasks. Should we jump into the CRD or?
Yes, absolutely.
Okay. So the way you can extend Kubernetes to support custom resources. So there are native resources that come right out of the box, right? Pods, jobs, secrets, configs, many of those deployments, whatnot. But if you find yourself not having enough resources or able to do some task of something that you want to do, you can extend Kubernetes to create your own custom resources. And the way you extend Kubernetes to contain, to have the custom resource is through this thing called custom resource definition. Custom resource definition itself is another resource that Kubernetes provides. And within the custom resource definition, you define your custom resource, the name, which is the kind, you define the versions, you can define the behaviors, and what you want this custom resource fields to have. And then it has sections where it validates the field. So for example, if someone's using your custom resource and they're putting a field that is wrong, it's going to bark back and say, hey, I don't understand this field. So it's a very, very powerful resource that you can use to extend Kubernetes. And another very important feature with the Kubernetes custom resource definition is that you don't need to recode or recompile Kubernetes to bring on this custom resource. Basically, all you have to do is add the custom resource definition, and boom, your custom resource, you can start applying the custom resource. So I'm going to say a little bit more about the custom resource definition, and which that is itself plus the custom resource is just a definition, right? It doesn't do much. And what's at the heart of this is creating your custom controller. So we talked about the controllers that comes with Kubernetes, but we can also create our own custom controller, and this custom controller will watch the custom resource that was created. So with that said, when you have custom resource definition and your custom controller, and remember the custom controller is where you can define your business logic. So it's a piece of software and it sits outside of the cluster, right? And it's deployed just like any other applications. with that, so three things: business logic, custom controller, and custom resource definition. That is what we call the operator. And when you Google and you're like, okay, what's an operator? A lot of times it says operator's pattern. That's what they mean. The pattern is three things: as I said before, the custom controller, the custom resource definition, and the business logic. I hope that makes sense. It took me a while to figure
Yeah.
it out.
No, no, it's make perfect sense right now. So I think if everybody who's listening to us right now, they actually understanding like there are controllers in Kubernetes pre-packaged up. If you have any resource in Kubernetes, you have controller associated with it. Either it's be a pod, deployment, replica set, cron jobs, service, deployment, anything you can see it, they have controller. But the job of the controller is to reconcile is what is in the cluster and what is the actual state it is. And if it detects the desired state from the actual state, and this its job is to make sure your desired state is met all the time. Now, this means if you need to add your own things in Kubernetes, you can do it. And Kubernetes APIs are highly extensible. So, meaning if I need a resource, let's say called to do resource, I need to create a to do resource in Kubernetes. And then the next job is to create a controller that actually watches for to do. And you can actually do the same work that Kubernetes is already been doing. So the next question is obvious. We talk about Kubernetes controllers, we talk about custom resources, talk about operators. Now, the next obvious question people are listening to us right now: why do we need it? What is the intent of extended Kubernetes? And what are the ways, like, which are the use cases I want to extend Kubernetes? And if I doesn't do it, what are the pain problem I have to go through?
Right. Okay, so what makes operator useful? There's several things. So there are applications that are very, very complex. For example, there are many, many microservices, and they connect to the backend database. And maybe their company has grown and they need a lot more microservices to support maybe data ingestion and log metrics and things like that. With what is out of the Kubernetes, out of the box, you're not going to get that custom support. You're going to get deployments, you're going to get requests, you might get highly availability resources, but you're not going to get that very, very customized way you want your applications to give you metrics or logging, or even so sometimes you don't want to expose all of your applications fields to, for example, somebody's that is using your application. You want to expose very little of what you want the user to see. So custom resource is really good for that. You can hide secrets, you can hide things that are common, you can hide database connections. So all you present to the user is the basics, the default, and they can use that, they can apply to it, and then your application is boom there. So high complexity is one of them. Another one is, say for example, your application, and that's what we call the operand. Your application, you decided to add features and you want to release it. For sure, you can use deployment to do, rollings and release it. But another way to do it is put that in your custom resource. Like the image you want to use, the version. So, and then in the back end, you can tell Kubernetes using the native deployment resource how you want this new version of your application or operand to release to your customers. So it's a lot of power, a lot of control on your end, and And not every user needs to know that everything goes into a very, very complex application. So we've covered a lot of automated operations and custom behaviors. You want deep application specifics. And with the custom resource, you get everything that comes with Kubernetes. So you can use cri-o, you can use the logs, you can use pods. So basically, you get a native Kubernetes, right, experience. And then, of course, when you have a custom resource, you have consistency. The operators provide a consistent way of managing applications across different Kubernetes clusters. All you have to do is give it the operator and say, hey, install this on your cluster. So there's a consistent way of spreading out to all the clusters. So in summary, operators makes it a lot easier to manage very complex stateful applications by automating a lot of the manual work, like the task that you have, and scaling out and managing the application. And I will demo you a operator that is that we've written. And so this application, in fact, before you even start the application, you have to seed the database. You have to run some things, and before you can even start the application. And one of the things that you have to run is create a database. And so with custom resource and a custom controller, you can hide all that. You can build business logic in. For example, you can put an init container in your deployment, and you can say, hey, if my seeding is not done, I'm not going to start my application. Or if the database is not up and running, I'm not going to start my application. So all those things that you can build the business logic into your operator. I hope that helps.
Yes, absolutely, absolutely. I think I think if you one of the ways you can look at it, the operator, why these are important. Let's say, like, I give you the one scenario that one of the tool is currently in the CNCF working like this. And let's say you can, if you want to create resources in the cloud using the Kubernetes API, and let's say, and can give you the more naive way of telling you, like, let's say if you can create resources in the cloud using Terraform, and you spun up EC2 machine using Terraform, but me as a team, let's say, accidentally delete the cluster by logging into the dashboard in the AWS console and delete the cluster. But Terraform doesn't tell me on the dashboard like if something is being deleted. Let's say I want to create a infrastructure, and the same way I created a Terraform, let's say, using the code and created an EC2 machine in the cloud. And if somebody is accidentally deleted the cluster in the cloud by going into the dashboard, I want Kubernetes to tell me that something deleted and is spun up a new cluster inside of the same EC2 instance. So
For sure.
let's say this should be a need. And there's
Yeah.
a project is actually in the CNCF is doing similar things like that. That's called cross-plane. So that's one way of looking at the CRDs. But there are plethora of different ways. Sometimes is automation makes very easy. Sometimes you want to build a controller in a Kubernetes cluster that can actually adds label into a specific selector every time you created a project. Let's say you created a new project, new cluster, and you created a label or the custom created every time the new cluster is created. By default, the project name is created for this cluster with a specific type. That's one of the use case. Sometimes you want that there's a Kyverno policies in the cluster. If somebody don't have a policy or is actually the resource limit or the memory is not defined in the YAML file, you create a custom controller. And the job of the controller is now, every time they see a pod without having a CPU memory assigned, it's created that. So there are plethora. I think I need a full 2, 3 more days to explain how of the different ways you can
Right.
extend Kubernetes. But in short, the summary is like similar to this. But if you have some more opinion on the chats, you can tell us how you are extending Kubernetes cluster on today. The next question we talk about, I think we talk about what the controller are. We talk about CRDs. We talk about the use cases. The next question is, if I want to extend or create a controller, can you tell me what are the different ways I can create a controller myself?
For sure. Thank you, Sam. You can write it, so you can create an application, and it can hook in. You can use a lot of libraries that Kubernetes use. You can hook in through API, and with that, so you need a controller, which is a software itself, and then you're gonna write your own CRD, um, custom resource definition, and apply that. And of course, so with that, those two. It's very tedious to do that because, especially for custom resource definition, there's a lot going on. I can show you an example of if you want to do that manually, it could be, user prompt. So there are a lot of tools out there, and I did a Google, and there is the thing called the Charm Operator Framework, and I looked into it. Every one of those is a little different. There's a Java Operator SDK that you can use. Yeah, so if you're a Java developer, you can use the Operator SDK to create operator. There is KOF, KOPF, it's called Kubernetes Operator Pythonic Framework. I think that's a Python kind of, you can code in Python to create operator. And there's a Rust one, there's the Kube Builder, and the Kube Builder is kind of the one that we embed. So I primarily work on Operator SDK, and Operator SDK sits on top of the Kube Builder, so I'm more familiar with that. And so then there's the Kube Ops, there's cri-o, there's Mast, there's a whole list of it, and then if you don't want the list, I'm happy to provide that. So with that said, and I said earlier, I use the Operator Framework, that's from Red Hat. And within the operator framework, we have several operators. We have the OLM operator, the operator lifecycle manager, which manages the operators that are in the cluster. So it's really good. You can install it kind of like very GUI-like, so you don't have to use command line. So you can just click install, and it will install an operator for you. But it's the Operator SDK framework that we use to create operators, and it's pretty easy. Basically, you download the command and you say Operator SDK init, and that creates all the file systems that you need to create the operator. And then when you say Operator SDK API, and that's where you add your own API resource. And basically, it creates a framework and boilerplates for you to really focus on the business logic of what you want your controller to do. And Operator SDK right now also can take like Helm chart. So if you have a Helm chart already deploying your operator, you can take that Helm chart, and it will use it to create an operator for you. And also, you can create an operator from Ansible playbook. And all of so for Helm chart itself, you can only go for like the capability. We have a capability level chart in for operators, and for Helm chart, it can go up to like level 1, level 2, which is install and update your operator and your operand, but you cannot do like level 3, 4, 5. Level 3 is backup and restore. You can't really use Helm chart to do that. So you're going to need either Ansible or Go to do that, Golang to do that. And then the level 4 is metrics, is observing, your cluster metrics, alerts, stuff like that. So it works much better with Golang. I haven't tried it with Ansible, but it says it can do it. And then there's the level 5, which is autopilot, which is it knows when you need another pod, or it's like for scalability. It actually embeds the HPA resource in it. So different levels, different maturity levels of operators that you can to start with, you can use the operator SDK to do that.
Yes, absolutely. And I think like next obvious question, and before I think that definitely you look at give us a highlight tour of what the OperatorHub.io is. But I think the most technical question for the platform engineers and the developer is, let's say if developer written an operator for Kubernetes, and I think developers might be looking like similar, like they created a code and then they added this code into the library, and everybody has access to the library. They pick up the code, the already written in it, and they start doing the usual work with it. Let's say if I extended Kubernetes cluster, and I'm actually having my own cluster, the vanilla Kubernetes cluster. Now I have wanted to extend the Kubernetes cluster that is public Kubernetes cluster, might be in the AWS, Azure, GCP. I want to extend it. The number one question is, if I extended the cluster, that my own vanilla Kubernetes cluster, can I, using the same code for extending the public cluster as well? Like, can we do it? Number one. And number two, if I'm actually adding or building a operator from scratch, where do I put it so everybody else can use it?
Okay, that's a very good question. Thank you, Sam, for that. So I think what you asked is, if I'm developing in my own cluster and I want to now use it in a public cluster, can I still use the same code? I believe so. I believe that's why it's so good about it. The application itself can be deployed anywhere, and as long as you have a Kubernetes cluster, the CRD works across. The only thing I can think of that it wouldn't work is whatever is domain business logic. For example, if you're accessing AWS um, storage or something like that, you're gonna have to use the libraries to access those. So maybe something very, very particular to that. Another question is, if you have an operator and you have the image, where do you put it? Well, you can put it like, in my case, I put it in Quake.io. I think it's free to everyone, and all of my operators are in there, and it's specified to be public. But there are plenty of image repositories that you can add your images to, so anybody can retrieve it. Another place to put it is, if you're part of the Red Hat, we have our own image repositories that once your operator is certified by Red Hat, we have a place where you can put it. So there are several options to host your operator image.
Yes, and next, I think that we talk about for the developer's perspective. Now, for the platform engineer perspective, is I think that if they're listening to us, I think that's a very critical question to ask here. Is like, let's say from the platform engineer perspective, like somebody using the managed clusters, like they have Red Hat OpenShift, might be somebody using the Ranchers, and they have some pre-built platform that actually the team has developed. So now, in order to extend the functionality of the pre-built platform, I see people using like marketplaces to add their things into the marketplace. And when people now pick and choose the services from the marketplace and start doing the work that is not available in the vanilla platform. Um, but now, in this case, we're talking about OperatorHub.io. So how this approach is different from those approaches. Like people are already familiar with marketplace thing. Like we have a server Kubernetes cluster. They give us a place to add their open source projects into the server marketplace, and then people can use it. But what is the advantage of putting open source project in the operatorhub.io, and where are the different places people can use this controller, like it just for OpenShift or for few three clusters, or it's open for the worldwide community?
Yeah, so there are different levels, and there's the community operators, and those are open to anyone. So, and then there's the certified operators that, we do some massaging to it, we do some testing about it, we make sure it's secure, the pods, it's all logistically in tune with the all the rules that we test. So we have a testing sort of uh, we're building a pipeline to test all these operators before we ingest into our image repository. And then there is the marketplace, and those are also, they run through a bunch of tests so that we make sure that it's safe. But to start out, you can definitely put your operator in Operator Hub, and it's open to everyone, and you can use it with OpenShift or vanilla Kubernetes. There are some resources that are custom to OpenShift, for example, like the route. So if you're using a route in your operators, so you just have to make sure that you account for both vanilla and OpenShift specifics. So you would do, a condition where if you're in a OpenShift cluster, then use route. If you're not, then use the ingress, things like that. So I hope that answers your question about, the different
Yes,
types of operators.
yes, absolutely. So let me share my screen and let me give a people high level tour of operatorhub.io. And plus we give us tour of OperatorHub for sure, but we can give people an overview of how to add an operator in an operator.hub.io. Can you walk through for these of the step that now is sharing on the screen? uh,
Yeah, for sure, for sure. Yeah, this is so on the top you see different technologies, and on the bottom you see that too. So you see the operator, developer, you or me, and then you see the operator SDK that itself is a framework, and then the OLM itself, it's actually two operators. So so those are the OLM is operator, and then the operator hub.io is a website where you can uh, see a bunch of operators, but it's also a place where you can submit your own operator. So, and then the GitHub is GitHub. Okay, so the first thing you need to do if you want to create an operator, and this is a very high level view, okay? You want to create a project. So number one is you use the operator SDK framework to create a project. As I said before, a couple steps, operator SDK, init operator SDK API, and that will give you a framework, a boilerplate, generate a bunch of files directory for you. And then and then after you created all that, you want to create your catalog data. And I can show you that later on my screen of what that really means. Basically, you would use like operator, actually, in Operator SDK, when you download it, it gives you a bunch of scripts, like the make file. It can help you along with, so you don't have to write out all of your command lines. So what you do is you would say like make bundle. So make bundle will create a bunch of data for you. It creates the CSV, it builds the CRDs and anything you need to create that image, your operator image. And then what you do is you can test out your operator with OLM, and you would then there's another command, and it's not here. Like I said, this is the overview. This is a very high level view. But the next thing you do is you want to test out your operator that, now it works in my Kubernetes cluster. So once it works in your Kubernetes cluster, then you can use operator hub.io. There's a page in there that says, hey, Give me your CSV, and CSV is very particular to OLM. CSV basically has all the operators, RBACs, the rules. It has the CSV, it has the CRD in it. It has the description of your operator. It has like an example of your CR. It's very, very OLM per se. And then once you preview your cluster service version in the OperatorHub.io, it looks like everything's working fine. And then you can create a pull from, there's a GitHub page, and we can share that with you. Actually, it's in, if you go to OperatorHub.io, it tells you where's the GitHub address, and you can, you have to clone the entire repository, and then from there, you make a pull request, and what it wants from you is that it's within. I can show you in here, but basically you have to submit the bundle directory to the GitHub, and then once you submit the bundle directory, and that contains everything that pertains to the operator, and after they validate it, and then you will be able to see your operator on OperatorHub.io. It might seem like a huge task right now, but once you go through it, it will make more sense. But this is the overall arch, sort of what the steps on how to get there.
Yes, absolutely, absolutely. And just give people a little tour, and then I will circle back to you once more again, so you can actually give us a walkthrough. So can you, now I'm actually going to the OperatorHub.io website, and can you give us a high-level walkthrough? If somebody's on the OperatorHub.io, what are the way to actually pick and choose these stuff? Like if is there a category like if to add services related to like Kubernetes access management, networking, big data, AI, ML, or if there is a not a category? And number two is a good question. If there's a not a category in this list, and I still want to push my operator into the Operator Hub, is it still acceptable?
Yeah, it actually asks you the categories, and on your left-hand side, on my left-hand side, you can see all the categories. For example, if you want databases, if you click on database, you'll see a bunch of type of different database from different companies. Yeah, like the Crunchy is the one that I've used, so there's plenty of that. And also you can look at, if you go to the left on the bottom, the capability levels, it tells you. Go up a little bit. Go back up. Go back up. Back up. Back up. Up, right there. Go down a little bit. It's on your left-hand side. Go down on the left-hand side. You see the category? It says capabilities. Right. So that's, I don't know if you remember when I was talking about different capability levels. You can have your operator just be able to install, upgrade, full life cycle, deep insights, and autopilot. So yeah, and then you'll be able to see how many of there are. And there's a number next to the capability level, and you know how many of the operators are, autopilot. There's not many of them right there. And that is our team's intention, that we want to help everyone to bring your operator to the capability level 5 autopilot, because operators, there's so much to offer in the way you build an operator. So there's not many out there right now. And then if you go up, if you want to contribute, there's a link on the right-hand side. If you go down to contribute, upper right-hand side, go up. It's in the blue band. It's actually on the panel. Contribute.
Oh, yes, there's a contribute, yes.
Yeah, and then there it tells you how you do it. Yeah.
Okay.
Submit your operator. Submit the bottom one. Submit your operator. Okay, yeah. Yeah. So
Yes.
all of that. And
So
so,
there's a way to tell like how to create open
mhm.
pull
So
request and
here's the
all
full,
information is actually there.
yeah,
Yes.
it's all in the
Yeah.
fine
So I'm
line.
just yeah, and just one quick question. Like I can see there's a provider section in here. I can see there's a provider section in the left side, left of my, and it's tell the all the provider in there. Like we have CNCF, Community, Comwat. Let's say if some companies wanted to add their open source project, so basically they first become a provider, and then they actually add their open source project as well, or any controller.
No, you can just add it. I think that that provider is a generating list from the metadata
Okay.
that you have to submit. There's a lot of
Yes,
metadata
got it.
in the bundle that you
Got it.
submit, and then it's annotations in there. So yeah,
Yeah. So
it's
basically, it's help in filtering. Actually,
yeah, it's
yes, got
useful.
it. Got it. Great. And so basically, like if anybody, like once again, if anybody want to contribute, like they want to submit their operator, what they basically do is they go to the contribute section, and they can click on the submit your operator section, and then actually eventually go to the github.com operator tree and operator section in here.
Yep. Yeah, you
And
can go in it, and I can show you.
yes, I absolutely. So let's me pause in here so you can share your screen as well.
Okay, let me share my screen. Give me a second. Um, okay. What what do you want me to share? I guess I can share. Are we going to look at the Are we still looking at the operator hub, or do you want me to show you how to deploy an operator?
I think like we can give a one tour of the. There's a repository link in here,
Oh yeah, okay.
and
Let me do the
yes,
repository.
community operator repository.
Yeah,
So we
okay.
can give a high level overview
Yeah,
of what the folder structure would look like.
yeah. Okay, that sounds good. So I go here. Here you go. The folder looks like this. So you clone this. You say, clone it into uh, your local machine. And what you want to do is in the operators directory, you would add your operator right here. So this is all the ones that are what you see in the operator hub. So you will add your operator here, and what it consists is not all your source code, right? It's just these files. It's the manifest directory, the metadata. Um, this is and I guess you have to put in your bundle Docker file. I'm not sure that, let me look at another one. Basically, that's the way you do it. And then within the manifest, this is where all the stuff lives in. Like when I said the CSV cluster service version, this file here, this is kind of like the mother load. It has everything, all the RBACs and all the configuration, an example of your CR. So this is created by Operator SDK. So it's very, very OLM, very Operator SDK. But it's streamlined the way we create operators. And then what you were seeing earlier for the categories, okay, I'm not sure about the details, but I'm looking at where is the category. I believe it's still in the manifest. So anyway, this is where you add your code, and then so you PR in there, and then once accepted, you're going to be able to see your operator in the operator hub. So I hope that helps where you would do it. Um,
Yes, got it. Absolutely got it.
do you want me to show you the deployment of an operator? Would that help? And
Yeah, yes, go ahead, Rose. What are you asking?
oh, I was saying that, do you want me to showcase how to install an operator and its CR and the actual application? I don't know if that
Yes,
works.
I think like what we can end. I think yes, absolutely.
Cool, cool, cool. Okay,
Yes, I
so
think like
on
we can end a note here. Uh, Yes, I think we can give a user of in a few minutes, like we can give a high level overview of like if they want to create a controller, they can clone a repository, they can make a repository. We can give them some high level, and then we definitely I will be up for the second part where we can tell how to build a controller from scratch, all the way publishing this into the OperatorHub.io. But we have few minutes left for the top of the hour. But I think we don't really want like if you have some example like if a pre-built package operator available, so you can give us a high level of what are the how the SDKs and how the layer down of the structures we're going to look like, like how the SDK files and all that stuff.
okay, I can do that. Um, I want to kind of start where we think there is an opportunity to create an operator. So basically, there is this application written in React. It's got a front end, a back end, and a database. And I'm going to try my best to get it right on this code. So basically, this is and it's all open source. So please, take a look at it whenever you want. Okay, so this is the actual operand. We call it operand because it's the application. So in this case, in order for this application to be available on the website, you have to do a bunch of commands first. For example, you have to install a bunch of tooling. You have to see the database. See this one here, number 7 says you have to see the database. You have to run commands. So it's tedious. So the issue here is if the pod is down, container is not available, then you have to go through this process again. So it's very manual, and that's when we started to think, hey, this is an opportunity to make an operator. So the first thing we needed to do was to make this containerized. Well, I mean, containerized, not particularly Dockerized, but containerized. So what we did was we took all the code and everything we need to do step by step, and we put it into the Docker file, and it did everything we wanted to do. We had a base image, we copy files, we build it and such. And so the next thing to do is, well, how do we put it in an operator, and what do I do with the database? As far as right now is in a Postgres database, and so the resolution we had was, hey, let's use a third-party database. It's crunchy data, and it supports Postgres database. And the reason why we went with crunchy is because we didn't want to change Postgres database to another kind of database. So, and that this is kind of like preset our operator day one kind of stuff, how we create it. So we use operator SDK, and we we added a custom resource name. We call it bestie, and we gave it some fields that we want to expose to the user, and we started from there. So what it looks like, and this code is open as well, it looks like this. And what in here is what I wanted to show is where we created the API, the besting API that extends the Kubernetes custom resource. So it goes in this file, and basically in the for the CR, for the custom resource, there are a couple fields, and we wanted to showcase the image and the version, so we can always upgrade the operand without having to restart the operator or, create a version 2, version 3. We just wanted to be able to upgrade the operand anytime we wanted to. So that's where it is. And we created some business logic because, as I said before even before the application starts, we needed to seed the application with some data. So we put it in here, and that code itself is in there's a lot of code here, but I wanted to show you it's the YAML file that created that. So we put it in resources, and basically this is everything that we deploy for this operator. So we deployed a deployment, we have an ingress, we have a job. So the job is where we seed the database. As you can see, the command migrate flags and upgrade. So this is where we do it. So going back to all the YAML files, we create route, create service, and here is the Postgres cluster. So we added a third-party operator in it. So that's just the operator. So now we're thinking about, well, how do we deploy the operator? So in order to deploy the operator, this is the file that it needs to have. And basically, this file contains a manifest directory and a metadata directory. And mind you, we don't write any of this code. We just add the fields and the resources, and we use some tooling from Operator SDK to build out, to generate the CRDs, the CSVs, all the files needed to deploy. Okay, so for example, in this manifest, there's several files because this operator is a level 5 operator. It knows how to create metrics. It knows how to expose metrics to Prometheus. It has alerts. It's autopilot, kind of autopilot. So that's why it has a lot of files in here. And all these files is deployed onto the cluster when we install it. And so once we install it, this is what you see. I hope I didn't miss anything. This is what you see in OpenShift. And this operator runs on Kubernetes, vanilla Kubernetes as well, right? But I'm showing you in OpenShift because I can get a cluster in here. Okay, so basically when I look for the L5 operator, I see this, and all I have to do is install. That's what's good about OLM operator. The OLM operator using the CSV manifest creates this very, very easy to use, light touch kind of, feel like just GUI, very much GUI-like, so you don't have to worry yourself with a bunch of manifest file. So I install it, and I accept all the default, and now my operator is installing. So the operator itself has a controller, and the controller is the one that will deploy my application, and you'll see in a second how it deploys. So right now what it's doing is adding the CRD to the cluster. It's adding the application, the custom controller, to the cluster. And maybe, I don't know, when we don't have time, but the next time I can show you where it actually sits. So when I create an instance, This is all in the CSV file. So this is very, very, very pretty. And this is my custom resource now. The custom resource, like I said, it takes an image, uh, it says maximum replication because this is autopilot operator, and I want 3 pods running, and the version's at 1.3. So anytime I can change where is the image is coming from or the version, and I can get another output, another application up quickly. So, okay, so now, and it has we created a, we added a status so you know what's going on. So wait a little bit, and we'll go to the route. It probably takes like a minute, but you'll see the application in the on the web. So route, but I don't think it's there yet. It's still instantiating. And I just kind of want to emphasize how important is day 2. To not disturb your customers, to have the website always running. You want to be able to create a new version of your application just by changing your CR. That is so powerful. But you can't do that if you're, just using the out-of-the-box deployment tools. Because, you can do that, but it just takes so much more energy. So, you have to know where to change it. But for this one, if you have someone who's just taking care of the application, you can just tell them, hey, go to your, apply another custom resource and changing the version. Let's see if it's up. See, now it's up. I don't know if we have time, but I can change the version and show you another version of this application. But this is how fast things can go when you have an operator versus if you have a Helm chart or just deployment manifest. It's much more difficult, complex to do that. This makes it a lot easier. Yeah, basically.
Yes, absolutely.
Yeah.
Yes, absolutely, absolutely. I think we top of the hour, but we have another. I think we can spend more time on telling people how to do it from the scratch, all the way to the OperatorHub. I think this might be the resource people are looking at it, but I think I think the way you actually deployed it, the application works, it really tells us the need for the actually controller as well. So I think we have just 1 more minute left before we wrap up the conversation. So we will join again with Rose and might be the few other members of this Red Hat team. But thank you very much for the wonderful insight of today's conversation. I think I learned a lot about wonderful things about Kubernetes controller. And the last thing you did, how easy it was when you have a predefined controller in place. It's just a click of the button and your application is deployed, rather than you creating the surface and controlling and all things doing manually. It took a lot of the time, and plus meaning controllers, you can add automation on top of it as well. So I think hope people can like the conversation as well. And if you do have some questions around these things, here's a show note on the GitHub repository. File and ticket or an issue or the question and raise it, and I will ask Rose to join us again, and we will be answering your question going forward. But you definitely expect to see another session on this. But with that, thank you very much for joining me, Rose. It's really a pleasure talking to you. And there's a next guest on the next episode joining me as well. So I will be joining you again. Stay safe, stay healthy. Bye-bye, everyone.
Thank you.
I'm Rian. I work work as a marketing specialist at Mia Platform in London. I'm super excited to be letting you know that Mitch and I are going to be speaking at the Cloud Native podcast on the 28th of July 2023. The podcast is going to go live 8 a.m. Pacific time, 5 p.m. Central European time, and we hope to see you there.
Hi everyone, I'm Michel Murabito and I am the developer advocate at Mia Platform in Italy. During the podcast, we will discuss platform engineering, we will discuss about internal development platform engineering, team culture, Kubernetes,